Hi, everyone. Thanks for coming to after lunch, coming to hear me talk about API composition. I'm Tina Huang. I'm the co-founder and CTO of Transposit, where we're building an API composition platform. This work that we've been doing has been largely inspired by the work that I've done building applications and platforms at places like Twitter and Google, as well as building early APIs as part of the operating system for OS X while I was working at Apple. So this should come as no surprise to the group of people here, since you are all at at GlueCon, sorry about that, and at the API track, that APIs are everywhere. And this is largely driven by the rise of SaaS, which has been great for all of our businesses. We have specialized applications for basically every aspect of our business that we need. But this has been, unfortunately, really bad for application developers, especially the ones that need to build applications that talk to all of this different SaaS. And that's primarily because data is moving outside of sources that you control and behind APIs. As Jeff Bezos famously said with the two-pizza rule, individual teams shouldn't be larger than what you can feed with two pizzas. And so internally, organizations are looking at API strategies, not only to decouple their systems from an engineering perspective, but also to allow teams to operate a lot more independently. And more orgs, well, they're adopting API-first approaches for actually designing and building out their products. And this is largely being driven by the fact that there are more and more clients. We're no longer in the world where you just have to support web and one or two mobile clients, but there's tons and tons of mobile clients that you have to support, as well as the rise of things like chatbots, Alexa, Skills, Google Home apps, and a bunch of different IoT devices. And so APIs are no longer just these shim layers on top of data models, but they're encapsulating more and more of that user experience that lived in the client. All of that logic is now getting pulled behind into APIs. And finally, basically all applications these days, they all have to be platforms. It's no longer effective for your application to live in a silo, but it needs to be able to play with all the other apps. And it does this by pulling in data from other applications, but also exporting its data to other platforms, all through APIs. So here we are in this forest of APIs, both internal APIs and external APIs, which is great. It's giving developers this higher and higher level of abstraction to work with, and all kinds of superpowers. Developers now have APIs for doing everything from sending emails through something like SendGrid or SMS through Twilio, and the ability to build really powerful DevOps tooling that sits on top of applications like CircleCI, AWS, and Slack. And increasingly, we're even seeing the database layer being exposed through APIs. When you think about databases like AWS's DynamoDB or Elasticsearch, and increasingly SaaS databases like Airtable. And so fewer and fewer applications are actually built from scratch. Very rarely do you see the application that looks like a server sitting on top of just a single database. And increasingly, our job is really about connecting and combining APIs to form new applications, and more often than not, yet more APIs. But unfortunately, connecting and combining all of these APIs rarely looks like snapping together Lego blocks. APIs unlock a ton of power, but they're kind of a pain to work with. Each API is a unique snowflake. Who here has spent more time than they really want to admit to reading the nitty-gritty of some API documentation just to get the thing to work? Wow, basically everyone here. That's great. It's sad for you as application developers, but great for people like me who are trying to help solve your problem. Well, a lot of this is because the APIs, more often than not, they reflect how the service owner is thinking about their data, and quite often how their data infrastructure is laid out, and not how you as a consumer of the API really wants to use it. For example, how they've chosen to cache and index that data, that often dictates what API calls you can even call. One manifestation of this problem is what I've often heard of called the N+1 problem. And that's where you're trying to fetch a list of items. and what really should be a single API request ends up being n+1 requests, as for each one of those items, you're having to do a follow-up request to get additional details. And another manifestation of this problem is with pagination. You know, when you want to get 100 results and you call 25, and then you get the next 25, and on and on and on. And we like to talk about pagination as if pagination is just one thing. But in practice, pagination means a bunch of different mechanisms. The most incredible example of this that I've seen is with the Slack API. Slack's API has 5 different pagination mechanisms, all for their supposedly one service, all sitting side by side. And who wants to guess how they might solve this problem? That's right. They're probably going to introduce a 6th pagination mechanism, one to rule them all. The same lack of standardization also affects authentication. But at least with auth, we're starting to see some consolidation with OAuth 2. But there's still tons of legacy authentication out there. And even with something like OAuth 2, there's quite a bit of variability between implementations. And so once you factor in all of these different API nuances and then think about things like rate limiting and retries, as a consumer of these APIs, soon your code just looks like some convoluted mess. And the real problem here is the complexity we're talking about is no longer just the complexity of a single application. We're talking about the complexity of interactions across multiple services that all have to communicate over the network. And so effectively what we've done with this API ecosystem is that we've made a world that all application developers, they need to effectively know distributed systems. Just take a moment to think about that for a second. Every developer, they need to know how to code against unreliable networks. They need their code to be resilient to long latencies. They need to make sure their code doesn't overwhelm those underlying systems. And only the most sophisticated developers, the ones that have extra time on their hands, are going to ever get around to doing things like optimizing for tail latencies. And so we all know that we have this massive developer shortage out there. My company is based in San Francisco, and I struggle to find enough engineers with the right set of skills. And now that we've really raised this bar for what it takes to be an application developer in this environment, we're facing this massive skills gap. And so what we need to do as an industry is find ways of lowering the barrier to entry so that more application developers can be productive in this API ecosystem. So at Transposit, we call this problem of having to write all of this glue code to connect and combine together different APIs the problem of API composition. And the reason we spend so much time thinking about this problem is the number of APIs and services, well, they just keep increasing over time. And the real bummer is the complexity of these interactions, well, that grows exponentially the more APIs and services you try to connect and combine. And there's tons of business use cases for composition. I saw this all the time at Twitter. So at Twitter, we decomposed the tweet into a bunch of different microservices. We had one service that returned the tweet, and another service that returned the user, and another that did link shortening, and on and on and on. And then we had a number of services like email, web, mobile, that all of them needed to do the same thing. They all needed to render a tweet. And in order to render a tweet, they had to compose logic that had to write all the same composition logic that grabbed all this data from all of the underlying tweet services. And at Transposit, we see this building against external APIs. We have a number of applications that, for instance, want to render a set of messages from a Slack channel. But even to do that, what seems to be simple task, well, first off, you need to take a channel name and convert it to a channel ID. Then you call that channel ID to get a set of messages. And unfortunately, every message returns the sender as a user ID, which is almost never what you actually want to display in your UI. So then for each one of those messages, you have to call an additional API to convert that user ID to a display name. And then almost every company has this problem where they're trying to pull together a full image of what a user is doing. And so we've built applications at Transposit internally that, for instance, connect together data from MailChimp, Google Analytics, and CloudWatch for our internal product telemetry. So whenever we talk about this problem of API composition, GraphQL inevitably comes up as some sort of relevant technology. And I don't know how many of you here are familiar with GraphQL, but in case you aren't aware of it, it's basically a new way of expressing APIs. And it came out of Facebook. And if you ask me, it's pretty well designed for the use case that they had, which is minimizing the number of client calls to APIs that they control. And while GraphQL is great, the problem that it solves and the problem that it was really designed to solve is what I'd say orthogonal to the problem of composing disjoint APIs. So one of the main benefits of GraphQL is reducing the number of calls that go, the round-trip calls that you have to do between the client and the server. But with GraphQL, you need to a priori define how different objects are interrelated. And then you have things like the N+1 problem that I spoke about earlier. Well, that's still a challenge with GraphQL. And there are some GraphQL engines that seek to optimize for this problem for specific databases like SQL databases or graph databases. But there is no generic engine that solves this problem for composing APIs across different services. So as we build all of these API compositions, we often find ourselves wanting to share this logic so that multiple teams don't have to build the same logic. As I described at Twitter, everyone just needed to render a tweet. And given that we have this massive developer shortage, we really want to be able to share this code to maximize its utility. And sharing has benefits that are about more than just the initial cost, but as we've talked about, this code is often really tangled and messy, and if you combine that with the fact that APIs are ever evolving and ever changing, this code is actually very hard to maintain. And so finding ways of sharing this logic can also allow us to amortize that maintenance cost across all the different clients that use this code. And consolidation also has benefits to the users. We've all experienced this as consumers where we work with an interface for a company, and depending on which side and which product you're talking to, you see a different view of their data. And then there's performance and reliability reasons why you might want to not just share this code, but actually encapsulate this code in some sort of centralized service. For example, when you want to introduce caching, either to make a set of API calls more efficient or because you want to make sure you protect those downstream dependencies from being overwhelmed with calls. Well, collectively caching allows you to actually share those cache results across all of your clients. And then if those downstream dependencies have rate limits, having a centralized place to manage this can be more than just an optimization, but can actually be quite a necessity. Being able to make sure that one client in one part of your organization can't blow through the rate limits for another. I talked to this one company, and their main application was their main product was this application that was effectively aiding the sales of some sort of loan product. And one of their backends was the Salesforce API. So their real live product talked to Salesforce. And at the same time, on a different side of the marketing org, they had a contractor build a syncing logic that was syncing between Marketo and Salesforce. And that contractor naively just called Salesforce too many times and blew through the rate limits. What this meant was the production application suddenly couldn't talk to one of their main backends, which was the Salesforce API. And so that basically meant that they had a production outage because of rate limits. So as you can see, centralizing this composition logic and being able to actually have control over things like rate limits can have a real impact on your end users. So what do we do now? We now get it. We're in this crazy API ecosystem. We need to write all this compositional logic in order to build apps that drive our businesses, and that we want to share this logic so that we can move faster and provide better experiences. But what's the best way to share this code? So assuming that your company already has some way of publishing and sharing artifacts, the most lightweight mechanism is probably just with libraries and modules. But there's some major shortcomings, and primarily, the fact is it's not a centralized service, so you can't do things like centralized caching. But there's also a total lack of governance with this model. Over time, you'll find many different versions of the same library, all deployed into production across different services in your organization. And there's basically no way that you can ever deprecate out old versions of a library. At a minimum, this means you're going to have disjoint logic across different products or different parts of your product. But more importantly, imagine that there's like a security fix that you need to roll out very imminently. How do you actually make sure that all of the different services in production actually force upgrade that patch? We've all seen horror stories. I don't know how many of you remember the left pad incident. That was 11 lines of JavaScript that when the JavaScript author decided to unpublish the artifact on NPM, it managed to break thousands of different projects all across the internet. Or there was the event stream library example. This was an open source library that was briefly hijacked for some sort of Bitcoin siphoning software. The hijacker instantly patched it to cover the tracks. But when this happens, how do you make sure that no service inside your organization is still running this compromised version? So I realize these are pretty extreme examples that all involve public libraries. But we've all seen this, where internally, very subtle changes to a library on one side of the organization could have far-reaching consequences to services on the other. So then we see this trend of moving towards microservices. And this is great. Microservices solve a lot of the problems because it's a centralized service. You have a centralized place to do things like caching and rate limiting. But this is actually a pretty heavyweight solution to the problem. For every new microservice, you need to allocate new infrastructure, configure how you want to deploy this thing, set up monitoring, figure out how to scale your microservice, and most importantly, you need to have a team that's willing to own and operate this service. At Twitter, I saw this all the time, where developer productivity is slowed way down every time we asked a team to move a feature out of our big monolithic Ruby on Rails app into its own separate service. And that's because the work that that developer now needed to do went from how do I build my feature to basically everything about owning and running a new service. Regardless of how many microservices you have in your organization, unfortunately, each new microservice you add still is going to have work that will scale linearly with every service you add. And so I'm not saying don't use microservices. There's absolutely times that you should use microservices. For instance, when you're encapsulating a major database in your product. And if your organization has a handful of microservices, you're probably OK. But I've talked to people who say that their organization has hundreds, even thousands of microservices. And if that's the case, I'd like you to consider whether or not some of what you're using microservices for is really encapsulating this sort of compositional logic. And maybe you should look for a more lightweight solution. So most recently, there's this third path called serverless. But what exactly is serverless? I'm going to argue it's a little bit of a misnomer. Because with serverless, there are still servers. They're just not servers that you have to run or manage. But at the core with this architecture, it's pretty neat. What it's effectively done is it allows a developer to focus specifically on the function they're trying to build and do zero housekeeping. They're not thinking about how to deploy, run, or scale this code. So I much prefer the term functions as a service. And the benefits of this kind of architecture are real. However, there are still new costs that introduce. For instance, you have to think about how to route requests into a particular function through something like an API gateway. And then platforms like AWS Lambda, well, they have a problem called cold start latency. And this cold start latency, it happens not only at startup, but every time a new Lambda has to spin up to scale that service. And unfortunately, this is something that you have almost zero control over. And on top of all of this, with stateless functions, you end up having, you still probably need state. So there's additional overhead that gets introduced for how to manage state through some sort of external service. So instead, I'd like for you to consider a more expanded definition of function as a service, where the platform does more than just running and scaling that service and that code, but fundamentally, it's about allowing the developer to just focus on the code and let the platform do all kinds of magic. And now, if we extend that core concept to the specific case of API composition, well, suddenly, that platform can manage all kinds of complexities and challenges around building with APIs and composing logic on top of them. So let's recap for a second where we are. We're in this world that we have a bazillion APIs, and this gives us all kinds of superpowers, which is great. But unfortunately, these APIs, they've taken our data and held it hostage. And unfortunately, all locked behind these APIs with a very steep learning curve. And what we ideally would like is to allow developers to operate at some sort of higher level so that they don't have to encode all of this excruciating detail about how to interact with every individual API. And instead, allow the developer to explain at a very high level their intent, what it is they're trying to do, and not how to do it. And while we're busy dreaming big, why not let someone else operate this as well? Does this sound familiar to you at all? Well, this is actually the world we lived in before the relational database. We had complex systems, data and lots of unknown structures, and tons of different mechanisms, way more than the average developer could hold in their head. And then comes along the relational database. And it gave us this high-level language in SQL, which allowed the developer to codify their intent and then hand it over to the database to do all of the mechanism of translating that to disk reads and writes. And who operated it? Well, it wasn't the developer. It was someone else who didn't have to know anything about the code that was being run on top of it, unless by chance that code happened to hog up too many resources. And so what would this function as a service for API composition look like? Well, I'm sure there's multiple ways you can approach this problem, but I'd like to share with you how we've built such a platform at Transposit and hopefully help you understand the properties that we think are really important to building such a compositional layer. So similar to other functions as a service, at the core, we want to allow the developer to focus on their code. But unlike traditional function as a service platforms, we don't think that this code should just all operate independently in this chaotic, decentralized ecosystem. We've centralized it in a platform both to allow for better collaboration, but also to give a better model for governance. We've also put in lots of built-in mechanisms around APIs and compositional logic, which really makes it so that your code is effectively being run in the context of a data pipeline. And this really removes a lot of the challenges associated with building stateless functions. We make caching and rate limiting as easy as a toggle checkbox so that it makes it trivial for the consumers of APIs to really protect those downstream dependencies. And we make versioning and branching primitives so that we make versioning and branching primitives so that we really encourage sharing and collaboration while remaining agile. But the real critical piece of all of this is pulling the tedium of compositional logic into the platform and giving the developer a high-level language to specify their intent and not have to think about the mechanics of how to call APIs. So at Transposit, we've chosen SQL as this higher level language that helps isolate the developer. But really, any sort of language that abstracts away that tedium from the developer will work. And so I'd like to give you a few examples of what I mean by focusing on the intent. So let's take this simple select statement. Here the developer is trying to say something very basic, like, I'd like to fetch a list of items. It seems really easy, right? Like, what is the mechanism here? Well, when this actually gets built into an HTTP call, there's all kinds of problems you have to think about. Like, how do I authenticate against this service? Do I need to sign the request? When the auth expires, how do I re-auth to get a new access token? If I'm not authorized, do I get a 401? Or I've seen API calls that give me some sort of error code in the JSON body. Or even just, what HTTP method do I actually need to call? What version of the API should I use? For every parameter, is it a query parameter, a path parameter, a header parameter? And which parameters are even required? And then imagine something that really should be pretty basic. I just want to get a few more results. Well, suddenly, we go to this world where you call list items, you get a set of results, and you're like, didn't get as many as I want. Let me grab that cursor out, pass it to another call, get another set of results, and then stitch these all back together in the end. And on top of this, we've talked about how pagination isn't really just one mechanism, but it's a number of different mechanisms. So on top of the complexities of just this rigmarole of having to paginate, the developer has to know for every API what mechanism to paginate. If it's cursor, what's that cursor called? I've heard it called cursor, token, other names. And then if it uses things like page numbers, you actually need to persist that through each call so that you can up it for every subsequent call. And then there's trying to connect together multiple APIs. And again, the developer should really only have to specify what data am I trying to retrieve and what IDs do I really want to connect this data on. And so here, again, we call list items. We get a set of results. We have to pull out all of those item IDs from each result, translate that into the ID for get item, hopefully fetch all of these in parallel, get a bunch more results, and then stitch it all back together. And these things are usually not done in isolation. Usually you need to do a bit of pagination, a bit of joining, and a bit of everything else. And in reality, your code probably looks a lot more like this. Once you factor in doing all these parallel fetches, waiting on your futures to return, and this is actually a cleaned up version of some simple code. We didn't even do any sort of error handling here. But aside from the pains of building and maintaining this compositional logic, it's also a lot harder for people to discover compositions that they would like to reuse. So imagine looking at this blob of JavaScript here on your left on GitHub. How likely do you think it is that you're going to look through that and realize that what this code's trying to do is give you the set of tracks of from a set of your user playlists from Spotify? That's probably not going to happen. But when we abstract away the mechanisms of the API, it becomes a lot easier to read that SQL statement and find pieces that you can reuse. It's also a lot easier, by the way, for a computer to deduce that as well. So I don't know how many of you have heard of this, but there's something called Hiram's Law. And it states that with a sufficient number of users of an API, it doesn't matter what you promise in the contract, all observable behaviors of your system will be depended on by somebody. So this can mean everything from accidental sort ordering of the results that you return out of a request to how short or how long that request takes. But what is inevitable is, as an API provider, you will eventually discover that you have, after the fact, broken somebody. So we've talked about how centralizing into a platform can help with governance. But if you combine that with various aspects of a good version control system, well, suddenly you've created a system that allows the API provider to quickly patch a version of their API after they've realized that they've accidentally broken someone because they were depending on something. So imagine the case that I'm an API provider, and I've changed the ordering of my results and found out that I've broken people. Well, first off, because I'm in a centralized platform, I might actually be able to get alerted because I now see 500s on a bunch of client calls to my API. And then I can instead decide to up the version of my API as I change the order, and then patch my older version of the API so that it passes a flag to my underlying system so that I can return the old sort order and unbreak all of those clients. So this problem of API composition is accelerating. Just think about how many APIs you used in the past, how many you're currently using, how many APIs you anticipate having to use in the future. So even if you aren't ready to build or adopt an API composition platform, there's still things you can do right now. For one, adopt internal standards. Please just select one pagination method, consolidate on OAuth 2. Adopt open standards. I know a bunch of you are part of the Open API committee, so plug to Open API. It's great. And function as a service, I think it's a thing. So if you're using the public cloud, every public cloud vendor has a version of this, and there's a ton of options for on-prem. But most importantly, think of your API as a product and manage them like a product. And think about how your API users really want to use your APIs. One of the most important lessons I've learned from my time at Apple is how to design APIs. One of the most brilliant things about Apple is they put the same effort in design care in designing APIs as they do with their consumer products. And that means they actually run user studies and talk to different internal developers as they are introducing new APIs. So one example of this is when I was on the Cocoa team introducing a new widget from their mail app and bringing it into the framework. So many of you probably don't remember the days before Gmail, but OS X comes with a native email application. And there's this field. You can type in an email address, you hit comma, it tokenizes it, it's a little bubble, it has a little drop-down arrow. And we called this thing NS token field. And we thought, basically, everyone was going to want to use this the way we were using it. Type in some text, tokenize on a character. But then we talked to this one team, it was the international team, and they just wanted to use it as a static little widget. They just wanted a bunch of these different bubbles around with cute bubbles, drop-down arrow. And so doing this additional user research, it allowed us to rethink the model for how we wanted to do the data source and really design an API that appealed to a much broader set of developers. So as an industry, we've been talking about this API lifecycle for quite some time. And depending on who you talk to, there's different components and pieces of it. But it usually involves aspects of composing APIs, publishing APIs, maintaining the APIs, consuming them. But I think that API composition is the next stage of this life cycle. And so whether or not you're already struggling with this problem of API composition, or you're just starting to see this as the future, I really urge you to adopt API composition as part of your API strategy. Once again, I'm Tina Huang from Transposit. We are open, so you can sign up and try it out at transposit.com. We have a free developer tier. We're also hiring, and please come visit our booth. I think I have about 5 minutes left for questions.
I actually do have one very brief question, which is, I understand SQL has a lot of advantages, not the least of which is that it's widely understood by people who do not have computer science educations, like business intelligence experts and stuff like that. But what was your decision to use SQL as the basis for your API composition language? as opposed to a somewhat more modern declarative domain-specific language?
Yeah, we actually get this question a lot. And so I think that there's many different aspects to it. The first part of it is there's some Stack Overflow study that claims that 80 or 90% of developers know some bit of SQL. And so I think that it's just very, very pervasive. I hear you where a lot of people think of SQL as how we give access to non-developers. But even within the developer community, I'd say, how many people in this room know SQL? And how many of you know how to write a GraphQL query? I think you can see, there's still an adoption problem with some of these new technologies. The other piece of it is SQL is actually a very well thought out language. It was built on top of relational theory. And so we think it's a very flexible language for defining basically what we need, which are these relational queries. And then I'd add to that, finally, the way we've built it on Transposit is we take the SQL and then we compose it down into some sort of intermediate form. So we can actually build, like we have a JavaScript API that sits on top of it as well, but we can build future GraphQL interfaces or even non-coding visual interfaces on top of it.
You talked about how the problem with non-standard pagination is a challenge for you. What about filtering also? How do you deal with the fact that there's no standardized way of passing some kind of filter criteria to APIs?
So the way we handle this is we detect if you can just type a where query, and if that name is a parameter, we just pass it through, and otherwise we filter it as post-processing. It's not perfect, but it approximates what needs to happen. All right, thank you very much.